Hi Chloe, give me a while. I need to reply once to the first time I will start also. Yeah. Or maybe I think we will just start first. I will just show you the question that you'll try and answer. So if you all want to unmute and answer, I think that even better. Can have discussion. Yeah, if you are not shy. Okay, can. So same thing as what we're gonna do last week. Today will be a revision mock paper thing. So there will be 15 MCQ questions followed by five structured, and then one long question related, something like a source-based question, application question lah. Okay. Yeah. Okay, come. This one. You all try to see what's the correct answer. Then we will go through. I fast reply one of the students. Chloe says A. Rental, eh? Okay, so okay, A is not correct. Okay, because right, okay, rental says C is the correct answer. So I will explain why A is the wrong answer. Because right, although they say there's no residue after filtration, I can think of an example where there's no residue, everything is soluble, but it's not pure. For example, salt solution, NaCl equals, right? So this is salt dissolved in water. But when I do filtration, definitely nothing goes through. But this thing is a mixture because it contains both NaCl as well as water. And it's not pure. Okay, this thing will actually melt and boil over a range of temperatures. Okay, so whenever you see questions that ask you or test you on purity, right, or testing for purity, you must always be thinking about two things. Number one, you should be looking for an answer that says fixed boiling or melting point. Okay, that's the one very unique thing about pure substances. Now, the second one you need to be looking for will be things which is over here. If you try and separate it out using a chromatogram, right, it will only give you one spot. That tells you that usually there's only one substance inside, which is pure. Okay. If any question, just feel free to stop me in the text box. Today I will go a little bit faster. Yeah, because last week it managed to. Okay, yeah, over here. Question two, colorless substance is made in an experiment. So which are the possible methods to determine if that thing is your same thing? Over here, they ask you about purity. So go again and try which of the three statements will help you to determine if it is pure or not. Randall says D. Chloe, any answer? D also. Okay, let's take a look. Measure the boiling, melting point and compare with the reference value. This one, yes, definitely. Okay, so if you have a reference value and you know that oh my whatever substance is supposed to boil at 50 degrees, you just check out is it really melting at 50 degrees or not? And whether it matches. Okay, measure the boiling point and compare also can. Test with paper chromatography and a locating agent also can. Correct. So answer here will be D lah. Okay. Anyone, can you share with me if you remember what is the purpose of a locating agent? Uh, this one is to test out whether you are remember. One. Randall says those chemicals that cannot be seen, like it is good, something along those lines. Because over here they're telling you have a colorless substance. Okay, okay, so basically, if you have a colorless substance, right, you try and dot it on the paper chromatogram, and then it rises, right? You cannot see because it's colored. Okay, so the locating agent is basically a colored substance that helps you to identify where your spot is. Yeah, otherwise you can't see you will not see anything on the paper. Yeah. Okay, so that is the purpose of a locating agent. Okay. So basically the keyword is visibility to make a spot visible. Okay, can. So those two were the experimental chem questions. Now we move on to the next chapter already. So this one will be your kinetic particle theory. Okay, so element T can undergo the following physical changes. So between solid, liquid, and gas. Okay, so which of the process or processes involve the particles increasing in energy? Okay, come try. No, no one. No. Maybe a hint, increase in energy, basically the particles must gain energy. So when we're talking about like state changes, right? Because over here all are state changes, which are the ones that require energy to occur? Chloe says D is 1 and 4. Okay, good. 1 and 4, I agree. So number one basically is our melting process. So yes, your particles definitely need to gain energy to convert from solid to liquid state. They need more energy to overcome the intermolecular process of attraction. Okay, then number four, this one is known as sublimation. I hope you remember this word, right? So sublimation means it goes directly from solid to gas. It definitely from being compacted together to totally free, right? Definitely need a lot of energy to overcome all the attraction forces also. Okay, so answer here will be B. Okay, can. Question four. Baking soda contains sodium hydrogen carbonate. So they tell you that the hydrogen carbonate, right, is this formula here. Okay, HCO3 with a single negative charge. Can you tell me how many electrons are present in one of these ion? Okay, this one, right, you might need a periodic table to help you. So get ready your periodic table as well as your calculator. Because later got some calculation questions. Yeah. And then once ready, you can give the answer. This is the one that usually people make mistake one. Yeah. Careless must be not let it go. Chloe says C, 32. Randall got any answer yet? Yeah, okay, okay, can wait. B. So it's either B or C already. Okay, can go through, then we'll see whether which one is the correct answer. So they want to find about electrons. Okay, so let's look at the hydrogen carbonate ion. It's made up of hydrogen, a carbon, and three oxygens. I don't know what the O is, the O, like not the 30. Okay, then after that, there is a negative charge also. So don't forget the negative charge. Okay, so we want to look at number of electrons in hydrogen. Okay, I got it. Okay, so hydrogen, by following the periodic table here, okay, so if you have a periodic table, hydrogen element number one means one proton and then also has one electron for the atom. Okay, so one number of electrons. Okay, then carbon is number six, oxygen is number eight, so it's three times eight. And then there's one electron extra, one plus one, everything together. Then press calculator, you will get 32 lah. The true answer here will be C. When you raise away the B, thing. That's why I say this one usually a lot of people get tricked one. So do be very careful. Look at the charge. And then some people they'll see oh negative charge, that means I must minus one in the answer. Then wrong already. Yeah. Okay, so those are common pitfalls I should share with you. Okay. Uh, okay, can. Number five, relative atomic mass of naturally occurring chlorine. So they're asking about the AR, AR, okay, of chlorine is not a whole number. Why is that so? Which of these following gives the best explanation? Because by right, you expect the whole number, man, or you cannot have half a neutron, right? Yeah. So, but why is it not a whole number? So, and so any idea? You know what should be done? Why? If you look at the periodic table, chlorine is a mass 35.5. Very big. Not a whole number. You are that go through. Mental says B. Okay, can let me go through. So you have to remember the definition of a relative atomic mass. So relative atomic mass, actually this one you have to pull information from your mole chapter, which I think if let's say a lot of y'all haven't covered in school yet, I think Chloe haven't yet. Yeah, then you might not know lah. Okay, so relative atomic mass, right? The keyword here is actually it's an average. Just started. Oh, okay. It is the average mass of an atom. Then the keyword is compared against compared to 1/12 the mass of carbon 12 atom. Okay. So the keyword here is average. Where average comes from is the average out of all the isotopes. So the keyword here actually now is isotope. Because we know isotopes are basically same element with different number of neutrons. Same proton, different neutron. And when your neutron number is different, your mass will change also. But the funny thing is you are dealing with the same element. So in this case, like for example, chlorine, right? You actually have chlorine 35, okay? And then it has 17 protons, element number 17. And then there is chlorine 37 also. Okay, so any random sample of chlorine, right, will contain some fraction of 35 chlorine 35 and some fraction of chlorine 37. So on average, whenever you take some random sample of chlorine, the mass is somewhere in the middle. The only reason why it is not a whole number is because you are taking into account the isotopes and their relative abundance. So answer here will be A. Okay, so they can have different number of neutrons. Okay, so keyword here will be isotopes. Okay, it's because of isotopes, that's why you have this kind of non-whole number value. Okay. Uh, some students may pick D because they think, oh, got mass electron, you include already, then got a bit more. But do have to recall that electron mass is very negligible, so it doesn't really impact that much. Yeah, it wouldn't be to a 1 dp kind of change one. Okay. Okay, question 6. You have a structure of glycine shown below. Okay, which of the following is correct? Hmm. So that should be quite simple one, I hope.